All right, here we go. Graphing linear equations. We've done this before. So what we're going to do here is we're going to take a little bit more time and look at what it means to be a linear equation and looking at what it is. Now, obviously you can take a look at those two and say, yep, they are not, or one is linear and one is not, right? I mean, the first one's got a curve to it, so it can't be. How we go through and check this is we want to identify the slopes. So if I look at what's going on with this, and remember your slope is always going to be your rise, which goes either up or down, positive or negative, and the run always goes to the right. And you have to check more than one set of points. So if I take a look at this one goes up 1, 2, and over 1, 2, 3. Now if I look at what this one is, this goes up 2, so that's the same, but it goes over 1, 2, 3, 4, 5. So because the slope is not the same between these points, it's not a line. I should be able to go up 2 over 3 every single time. Now I'm telling you this because you can't just look at it and say, oh, that's got to be a line. Because if I only showed you, say, do it this way. Say I only showed you, let's see this. Oops, wrong one. Get that. There we go. Say I only showed you that much of that graph. And that's all you've seen of it. That looks pretty darn straight, doesn't it? If you take a look at some of the things that you guys draw out, it doesn't always look perfectly straight, so you have to go by the points. So if I'm looking at this other one here, is it a line? Well, it goes up 1, 2, and it goes over 1, 2, 3, 4. If I look at the next point, it goes up 1 and goes over 2. Well, that can't be the same slope, can it? But it is, and here's the reason why. Slope is always going to be a fraction, rise over run. So if I take the first one I did here, that's 2 over 4. If I take the second one I did here, that's 1 over 2. Does 2 over 4 reduce to 1 over 2? Yeah, they're equal. So when we simplify them down, and if they are the same, great. Okay? So I'm going to give you a few moments to make sure you get this stuff into your little book. All right. Now, we're going to take a look at graphing these type of things. We've looked at these before. So this is just going to be mostly a review for you. What I definitely suggest you do. First offhand, we're going to take a look at X and Y. We're going to put 0 in for X. Whenever you have something in standard form, it's pretty good bet that you'll be able to go and graph it out like this and then draw your line and you're done. So if I put in 0 here, that means that, well, 3 times 0 plus 2y is equal to 12. The 3 times 0 is nothing, right? Divide by 2, divide by 2, so y is equal to 6. Does that make sense? Now likewise, if I go and put in y is 0. So if I say that's going to be 0, what would x have to be? 4. Well, because this disappears, and 3x is equal to 12, so that would have to be 4. So now we've got our points for creating the line. X is 0, y is 6. 1, 2, 3, 4, 5, 6. Always helps when I'm like that. And 1, 2, 3, 4. So now, I have all the information I need, and there's my line. Easy enough. So, what about the next one? We do exactly the same thing. I got X, I got Y. We're going to put 0 in for X. So if I put 0 in for X, that means I don't have anything there. So what's Y have to be? And if I put 0 in for Y, that means this is gone. What would that have to be? 10. So now, graph the points again. X is 0, Y is -4, so that's 1, 2, 3, 4. X is 10, puts me out all the way over here. So, draw my lines in. And there we go. That's it. So all in all, this isn't all that difficult when you see it in this form, standard form, where you have the X and the Y on one side and you got your 12 over there. Now, the only time that you really wouldn't want to use this idea is if the numbers don't go in nicely. 3 and 2 and 12, they go in nicely? No. 2, 5, and 20, they go in nicely. If you get ugly fractions, ugly decimals, then you have to do it in a different way. But this is a good way for doing standard form equations. So, what happens if I'm given this one? I'm in point slope form. Who wants to do all the distributive property? Anybody want to do that? Move everything around? Do all that algebra? Probably not. Now, this is y minus y1 is equal to m, which is our slope, x minus x1. And the coordinate that it has to go through is x1, comma, y1. Now, I look at this and I say to myself, hey, I can just pick the pieces out of here that I need. So I know that this is supposed to be y1 over here. Okay. This has to be my slope m, and this has got to be x1. So if I look at my y1, is this form exactly the same as this form? The answer is yes. So I just pull out the 3. Slope I don't care about, so that's going to be -1/2. Now I look over here. Is this the same form as this? And you should see that there's a positive sign here and a negative sign here. So is it the same? Do I have to do something to it? Probably. So instead of a positive here, I'm going to go minus -2. You know, negative, negative. So what does x1 have to be? -2. So just by looking at this, we know that it's going to be at the coordinate of -2, 3, our x1, our y1. So -2, 1, 2, up 3, 1, 2, 3. What's the slope? Well, the slope is -1 over 2, so that means it goes down 1 over 2, point, down 1 over 2, point, down 1 over 2, point. We've got enough points there. Identifying, oops, always helps if I put it in the right spot. So I got my points in the line. Goes through them, and there we are. That's it. So having to go through all of the process of solving it into one thing, putting it into something else, you can use these shortcuts. Use the information that you have to try and graph. So I'm going to give you a few moments, and I want you to make sure that you have this information. All right. We've talked about these idea of transformations before. And sometimes what we want to be able to do is take a look at an equation and figure out what's happened to it by going off of, say, a parent function or the original function that would be identified as a line. So if I see a negative in front of it, I know it's got to be reflected. Plus C, vertical shift up, plus C or minus C goes down. Then if we take a look at the multiples of it, well, if you multiply it by a number bigger than 1, it should get bigger, right? If you multiply it by a fraction, it should get smaller. So you ready to go on? I'm all done now. Some of you were scrapped. So. Okay. Now, I want to graph each one of these. First thing that I'm going to do is I'm going to graph this equation right here. F of x is equal to y. Well, f of x is equal to y, that's same as y is equal to x. There are a lot of ways that I can do that. I could identify it in slope-intercept form, knowing that the y-intercept goes through at 0 or has a slope of 1, so it keeps going up. I could recognize that if I was looking at an equation, y is equal to x, whatever I put in for x, I also get out for y, correct? And so that would just keep on going wherever I'm looking at. Or I could plug it into the graphing calculator, come up with a whole bunch of values for it, and write it down from a chart. There is more than one way to deal with it. So I'm going to make my line. Now, what I want to do here is I want to graph each one of these, but I'm going to do it the lazy way. I am going to take a look at what I have for my line and see what it should do. So I've got my line. Let's see. Now what I want to do here, we'll start this one off here with the red. Y is equal to negative x. What is it that the translation tells us should happen to it? What should it do? What does it do? If I got a negative in front of it, it's supposed to do what to it? Reflect over the x-axis. So that means whatever I should see on top, I should see on the bottom. So I am going to go and do this. Let's see, I want to flip. Do I want to flip left, right, or up, down? If I want it to go over the x-axis. X-axis. Up, down. So now, there we go. That's exactly what it looks like. Well, if we think about what the equation would be, y is equal to negative x. I put an X in there, I got to make a negative for the Y. So if I would put in a positive 1 with a negative in front of it goes negative 1, so it's down there. Let's check this one out. Oops. So I'm starting off here. And I want it to become whatever this changes it to. So if I've got X minus 3, what am I supposed to do with a minus 3? Which way is it supposed to go? If I go back here, it says is C negative. Well, if I were to look at this, could I rewrite this and think of it as Y is equal to X plus negative 3? If I do that, does it fit the forms that I see here? And the answer is yes. Plus C. Plus C is negative. That means it has to go down. So for this one, I would simply take this and move it down. How far? 1, 2, 3. So now I know that the green line is going to have to go down 3 places over. Now, the next one's a little trickier for me to do with this. So, what I'm going to do here for this one, it's still going to go through here at the origin, because I put 0 and I put 0. That's it. If I put 1 in there, what's going to happen to it? What do I get out? Wakey, wakey. Good. Well, if I put 1 in, what do you get out? Yeah, what number would that be? If I put 1 in there, what do I get out? What? Do you say 2? So it would have to be 2. So it looks like any number that I would put in there, I end up doubling it. So if I put in 2, I should get out what? 4. So my line is going to be looking like that. So what I'm going to end up having to do with that, I suppose I could just go back here, go back there, drop my line in here, but say it's got to go this and like this. It's going to end up changing its slope. So there's not much I can do about that right now. It goes up there. Like I said, it wasn't going to be as easy for me to do that. So it's going up a lot faster, isn't it? Everything that I do, any number I put into it's going to be doubled. So you'll notice how the slopes here were kind of parallel or opposite. This one's going up faster. So if that one's going up faster, what do you think would happen there with D? What do you think would happen here? If I multiply it by a whole number, it went up faster. So if I multiply it by a fraction, what would you expect it to do? Slow down. And there's a negative in front of it, so it's going to end up actually being on the opposite side. It's going to do just what that X did. So, and it's got a positive 2. So that means I got a whole lot of things that are going to happen here. So this one here is going to end up going up here at 2. Now, when I have all of this stuff here, graphing by transformation is a little more tedious to deal with than going by slope-intercept form, which is fine. This would be the better way of solving this particular one. So I'm at 2, down 1 over 3. 1, 2, 3. Down 1 over 3. 1, 2, 3. So I've got my points. There we go. That's where that line would go. But having an idea of what it's going to do is very necessary, especially when you're taking those wonderful ACT tests, MCA tests, Accuplacer tests, especially if it's a time test. Because if you've got a time test and you can take a look at this and see, hey, these are the attributes that it has, you don't have to sit there and go and plug in a whole bunch of numbers and see if you can figure it out. You can look at it and see what's going on. So, give you a few moments here, get these taken care of. All right. Now, when it gives you something like, it says, let B be any constant, all they're telling you is it's a number. That's all it's going to be is a number. So if y is equal to number, we've got a horizontal line. Horizontal lines are functions, not a problem. X being equal to b, well, that's not going to have the ability to be a function. It's just what x is. So we find where it is on the x-axis and draw a vertical line. Easy stuff. So if I want to graph these two for lines, what I would do. So I got y is equal to 3. Well, that's pretty easy. I'm going to go 1, 2, 3, y. Where's negative 2 going to go? 1, 2, negative on the x, and it's going to go up and down. Easy stuff. Where in the world would you use it? Well, here you go. What? Really? The ADA, American with Disability Act, specifies that a maximum slope for a wheelchair should be 1/12. Builder needs to install a wheelchair ramp from point P to the entrance door shown in the diagram. Graph a line that can be used to represent the ramp. Now, fortunately for us, that's 12 units over. So if I was starting with a line that would be here and put it over to 12, would that work? Would that be a rise of 1, according to over here, and a run of 12? Now, we would simply need to move it over here so that it's going from there. Now, I need to write an equation of that line. Why in the world would you need an equation for that line? Well, maybe you're actually putting this into CAD software and you're actually putting it down so that it's on the blueprints. So, I know that it's going to be y minus. This point here looks like it's going to be at what? Let's see, that's 6. That would probably be 3 then, right? So this coordinate right here is going to be 3, 0. So y minus 0 is equal to slope 1/12 times x minus 3. So that means y is going to be equal to 1/12x minus 3/12, or if you like, y is going to be equal to 1/12 x minus 1/4. So, nothing spectacular about it, but you need to be able to use those rules to go and plug things in. So what I want you to do here, I'm going to give you, I'll give you a minute here, and I want you to do practice problem A. See what you can come up with for that. So, is it a line? Is the slope down 1/2? Down 1/2. So because I have that pattern, I know that it is going to be a line. By the way, what about the next one there in B? Let's take a look at that one quick. Would it be? Would the graph that you see there represent a linear function? Absolutely correct. It's not. How do we know? If I put 1 in there, what number do I get? Do I want 1 or do I want 3? So there we go. Not going to happen. So here we go. We want to graph these. Now, it says using a table. Is there an easy way of using this as a table? Sure there is. I'll show you how. So now I know we can put in the 0. So if I put in the 0 for X, what do I get out for Y, Mr. Anderson? Hmm? Close. -2. So Eli, if I go and put 0 in for Y here, what do I get for X? 4. So do I have enough information there on a table to go and graph it? Okay. So when they mean you to use a table, you don't have to go and use a whole boatload of numbers, do you? You can just get by using the zeros. So X is 0, Y is at -2 is down here, X is at 4, 1, 2, 3, 4. So I've got my line going through those 2 points. Okay. Now I'm going to give you a minute or so here, and I want you to try and graph out. You just sketch out on your assignment or your notes or whatever for D. All right. So we need to have this in for slope-intercept form. Slope-intercept form, obviously, is going to be in the form of y is equal to slope. What's the slope going to be for this one, Mr. Levarsky? What you got written down? Now, a while back, I gave you a nice little trick for dealing with that. Slope is going to be equal to -b over a. Oh, -b over a. Remember, I'm confusing myself now. -a over b. Sorry. Yep. It's been one of those days. Bring over the a and then divide by whatever you got in front of the y. So, what is your slope for this one? So what's a? Well, a is 2. It's got to be a negative. And what's b? B is -5. So in actuality, do I even have to worry about those signs? The answer is no. Little trick. So, x. Where is this thing going through the y-axis? Well, fortunately for you, all you got to do here is take that and whatever they got to C, divide that by B. What's C? 5. What's B? -5. So that means
Allison Ann,
minus 1.
Melody, Taylor Odette, Tyson Gustafson, and Sierra Ann. Today's Snowfest winners for Day Junior High Gavin Polarski, Senior High Rachel Buck. Please go see Mrs. Bedbrotten in the concession at this time. Also reminder, after school is the last time that you can put any money in the buckets in the office for the penny wars. That's it. Have a great night.
And there's that line. Now the last one, we've seen the trick for that as well. So we can take that one. We've got our coordinate. Now mind you, this is x plus or y plus, so we should make this as minus 1, right? When you've got the plus, change it to subtract a negative. So that means this is going to be 4, comma, negative 1 for the point, and the slope is 3 over 4. 4, 1, 2, 3, 4, down 1. So my slope up 3, 1, 2, 3 over 4, 1, 2, 3, 4. 1, 2, 3, up, out of my way, go down the other way, 1, 2, 3, 1, 2, 3. Are they in a line? And there we go. So now, when you are taking a look at this stuff, you use some of these little tricks to make life easier for yourself. So assignments due at the end of class tomorrow. Theoretical.